This is page 36 in module 4. We're estimating with square roots. So the square root of most numbers is not an integer. You can estimate the square root of a number that is not a perfect square. So if all the numbers were perfect squares, then it would be very easy, right? So the example that we did in the previous page was square root of 25, which was 5 and 5. So 5 times 5 is equal to 25. So that was a perfect square. But notice how not all of them are perfect squares. So let's begin by determining the two perfect squares closest to the radicand, so that one perfect square is less than the radicand and one perfect square is greater than the radicand. So let's see this example. So to estimate radical 10 to the nearest tenth, identify the closest perfect square that's less than 10 and the closest perfect square that's greater than 10. So your first task is to put this right here in the middle. Okay, so this is your first step. So radical 10, you put that here. Now the closest perfect square less than 10 would be 9, right? Because we know that 9 is a perfect square that's closest and less than 10. Because we know a square root of 9 is equal to 3. So that's that, and on to the right side of radical 10, we're going to put the closest perfect square that's greater than 10. So we know that 11 doesn't count, 12 is not a perfect square, 13 is not a perfect square, 14 is not, 15 is not. But 16, yes, because 16, we can say 16 square root of 16 is equal to 4. So the perfect squares from each side, you're going to put that to the left side and to the right side of this radical that you're trying to estimate. So this means that the estimate of radical 10 is between 3 and 4 because we know that radical 9 is equal to 3 and the radical 16 is equal to 4. So this is going to be, we won't know exactly what the number is, but we just know that it's in between 3 and 9. And when we just locate it on a number line, let's say this is 3 and 4, we know that this radical 10 is in between these. But it's closer to 3 than 4 when plotted because 9 and 10, just by looking at those numbers here, 9 and 10 only has one difference. 10 and 16 has 6 difference, right? So it's closer to 3. So you would just plot it right here. But you don't really have to like plot it. You can just think about it in your head and just ask yourself which one is this closer to? Is it closer to 9 or is it closer to 16? And since it's closer to 9, we can say that it's more closer to 3 than 4. Okay, so we can just say that it's about this squiggly lines. This symbol means approximately equal to, approximately, or around, or about. Okay, so radical 10 or square root of 10 is close to or about 3.2. Okay, so let's calculate the square, not the square root, but square of 3.2. So to determine if it's a good estimation of radical 10. So remember, if it's a radical of square root of 10, that means those two numbers, we're trying to figure out the two same numbers that multiplied to get this number. So since we estimated that it would be 3.2, let's just figure that out by putting the square or taking the square of this 3.2. So that means 3.2 times 3.2. Which you can also write it as 3.2 squared if you use a calculator or just by hand. It's 10.24. So is this close enough? Yes, it is.